This is the tightest schedule that we've ever run at Java Dev. We wouldn't have chosen to do it this way, but we had so many good talks. And let me tell you, we had to reject about half of the talks that we were offered, some of which were excellent proposals. So if you are in the audience and you were rejected, I'm very, very sorry. It's not, doesn't have any slight on the quality of the proposal at all. In the end, we just have to put it down to what we can manage. Because of that, there won't be very much time for questions at the end of the talks. I would like to encourage speakers to use as much time as they can. Maybe it's okay to answer and ask one or two questions if there is some spare time. Otherwise, I very strongly encourage speakers to make themselves available at the end of their talks to people. So you can take questions outside and spend as long as you like discussing your favourite subject with people who are interested. But we have to run to time. I think that's basically it. I will now introduce. Sorry, what? You think you can speak? Yeah. This is a message about our sponsors who Mario remembers, I'm sure. Certainly we are very grateful to IBM and Oracle. And SAP. Yeah. And that's the last time they asked me to do this job. Without much further ado, I'd say I would introduce Mark Reinhold, but probably lots of you have seen him before. He's the legal engineer of the... At this point, I'm just going to step aside.
Thank you, Andrew. Good morning. Can people hear me? Yeah, the microphone. Okay. All right, good. So this has now become a tradition after all these many years. The State of OpenJDK, and it's the State of OpenJDK in two senses. One is the state of the community, and the other is the state of the technology. So I'm trying to intermix the two. I know that some of you are here not because you like to work on OpenJDK, but because you like the new job, and that's great. So there's stuff here for everyone. So our community continues to thrive and grow. This is a good thing. We've had 7 new projects approved this year. I'll talk about most of these later on. The Duke project, for those of you who don't know, is going to be a long-term home for all the Duke artwork. You may recall Sun open source Duke putting them under the ESD license back when OpenJDK was created. It was eons ago. We have a bunch of new committers, 14 new committers voted in this year. 3 of them are not Oracle employees. Those are the ones in orange. They're from school, Intel, or they're just independent. They show up and they do good work. We have 8 new reviewers. Reviewers are a higher level in our system than committers. They have the authority to approve changes going into the mainline code bases. There are 8 new ones this year. More than half don't work for Oracle. I take this as a good sign. This means that things are operating independently, and more non-Oracle contributors are moving up and gaining responsibility. So we've also made some progress on improvements in how we all work together. In some cases, these are projects, efforts that have been underway for years. So the vulnerability group is something we've been trying to create for 3 years now. Unfortunately, as with anything that involves lawyers, it can take time. It can take an unpredictable amount of time, especially when it involves lawyers from multiple companies all having to agree on the same document. So there it is. Anyway, I running in a matter of just a few more weeks, not months, and certainly not years. And this is all the more important now that we are firmly in the era of Spectre meltdown and probably an infinite stream of fund-side analog attacks going forward. Another improvement is the compatibility and specification review group. This was actually created just after FOSDEM last year. So a little bit of history for those of you who don't know. Sun had this internal group called the CCC that dated way back to 1997, really ancient times, whose job was basically to do this: ensure consistency, ensure quality, ensure that the changes to APIs and specifications coming in were consistent and so forth, and above all, compatible with everything. He continued to operate even during the even after OpenJDK was created, which of course is the source of tension because it's this internal thing that the external contributors have to somehow find somebody to help them deal with, and that's because it's not only not acceptable, it's not efficient. So we created a compatibility and specification review group in OpenJDK. As I said, was approved in February last year, right after FOSDEM. These are its members off consensus. It includes one non-Oracle member, Doug Lee, who knows a thing or two about API design. So that's good. Everything that the group does, all the proposals for specification and API changes and the reviews are in the JDK bug system. So if you're bored, you can go follow along and even comment on things. You have insights to contribute to the incoming changes. So it's all public, it's all there for everyone to see. Okay. Sure. I'll play school teacher. There are a bunch of seats down here in the front. Yeah, and also people could, we're going to do a back room. There's no reference counting here. Just move. do a good set of tests across all the different platforms. So last year, this was experimental. In the meantime, our Oracle's internal built-in test system has changed from the old system called JPRT, which you may have heard of, to this new system called Mach 5, which you may have heard of. And so it was offline over the summer, and we had to re-trigger a bunch of the back-end stuff. But anyway, it's back now, and it runs on Mach 5. We're still ironing out a few bugs. I don't know if Lexi got his email back to you.
No.
You never finally found out what happened to that account? No, I'm sorry. Well, Tim will track it now. He's very diligent at the account. Anyway, so it's no longer experimental. That's good. And if you want more information, you can find it on this wiki page. Please don't use it. There's no throttling on this. So if you wanted to, you could go push a gazillion change sets in here. But don't do that. We're trying to trust people, not set up variables. All right, another place where there's room for improvement. So this is a tricky topic. I've chatted with a few people about this. It's my sense that we've gotten to the point in the OpenJDK community where we need to get a little bit more formal about who maintains what. Right? There's obviously a bunch of code that everybody cares a lot about. If we have Java lang string row capacity, but there's also code that some people care a whole lot about, and other people, they're happy that it's there, but maybe aren't going to maintain it themselves, don't have the expertise, or don't have the hardware. So I've spent some time looking at how other communities handle this kind of problem, in particular the DCC community, and the Linux kernel, and the FreeBSD folks. There's not by no means standard, but common notion of having a maintainer's file at the root of your code tree that documents who is responsible for what, with some guidance as to, well, if you're going to go change something in this area, and you haven't been involved in it before, you can go talk to this person first. So that's been one source of inspiration. But also, I think we can do this just by observing what we've been doing informally now for a while, right? There are ports in the repo that weren't there 10 years ago. In some cases, weren't there 5 years ago. RDC AIX ports, S390 ports, AR64 ports, and these are all important things. But not everybody has the hardware or the knowledge to maintain those as changes occur in the core of the system that inevitably do affect those ports. And so, the informal practice, the sort of obvious one that's thrown out is, well, changes will happen to the common code. If somebody's working on, say, a big refactoring in Hotspot, they'll make sure that people who are maintaining all of the ports are aware of the changes coming in. But someone doing a refactoring in Hotspot is not obligated to go test every port. They might not even have the hardware to do that. So these other ports are maintained primarily by their maintainers. And if a refactor comes to the hotspot, then the maintainers need to keep up with that. So this is just an initial notion, and I'd love to get feedback on this today as we're chatting informally. I'm still not quite sure how to write all this down. I've taken a couple stabs at it, and the document just wound up too long. I wasn't sure. So here's a slide, the ultimate shortness. Let's see if I can condense it down. So 3 tiers, 1, 2, 3. That's pretty simple. A tier 1 feature or component or subsystem, I'm not quite sure what to call it, is something that's critical to the ongoing success of Java. It can be built and tested on commonly available hardware and operating systems. And if a build of one of these platforms breaks, or a build of one of these features breaks, then that's P1 time. It's hair on fire, got to fix it right away, and whoever made that change is their responsibility. Tier 2 is something that's important to some, maybe a whole lot of contributors, but not everyone. It might require special hardware to your operating systems in order to test. Build breakage of this kind of feature is a P2 bug, so it's important. You got to fix it soon, but you don't need to stay up all night in order to do so. And fixing it is primarily the responsibility of the maintainer of the feature rather than the person who 3 is a feature that's a candidate, or actually has been deprecated as a candidate for removal. This is what happens when a feature has no active maintainers, or if its maintainers have decided, okay, it's just time for this thing to go. Breakage of a tier 3 feature is a P3 bug. It'd be good to fix it. It's not showstopper to release if it's not. So these are really just symmetrical thoughts. As I said, I help with feedback and advice on this because it's been difficult to figure out how to write it all down in a way that doesn't get overly formal. All right. Another improvement. Now, to be honest, I'm not sure if this is an improvement. I'm not sure that everyone will like it. I'm a little bit queasy about it myself. All the cool kids these days. Oracle is actually a really big Slack. We've got Slack spaces at Oracle coming out of our ears, channels everywhere, and I have to admit, having used it for the last year and some, it's useful. I mean, it's like it's IRC with a better user interface. Although I still miss the terseness and let's say the low latency about IRC as opposed to large files of JavaScript running the browser. Anyway, so the Slack is around. It's really popular. A bunch of people find it productive. Should we get one? No. Any yeses?
Is it open source?
Any yeses who don't work in Oracle? Is it open source? No, it's not, and that's part of that. I'm queasy about that too. Is it a commercial operation that could disappear in 3 months if they don't get funding? Yep, it is. Where's all your data? Yeah, so OpenJDK.slack.com actually exists. I created it like 3 years ago. Before Slack was a thing. Thinking, well, maybe Slack becomes a thing, maybe something we want to use. I'm the only user, it's really fun. If we wanted to, we could make sure it has all the right IP stuff around it and open it up, and it could be used by contributors and others. But if the sense is that nobody would use it, then we won't bother. Should we bother? Yes. No. No's. Andrew is cleverly just. I don't know. Like I said, I'm weak about it. Would it be an improvement?
Well, as long as it has IRC gateway.
It does.
Yeah.
Is that your nose?
Yeah.
There is an officially supported IRC gateway.
That changes it.
Does that change anybody's vote?
Yeah.
Okay, so how many people say we should do that? Yeah. Okay, well, thanks for all your theory input. All right. Enough about that. What have we actually been working on? Well, the big thing that we've actually been working on, of course, finally shipped JDK 9 last September. This was a big release. We finally delivered Jigsaw. We finally delivered modular platform. Big change. We delivered about 100 other smaller features. Well, actually, some of them were kind of large. They just weren't as large as Jigsaw. So thank you to everybody who helped with this release. It was certainly controversial at times. I think its adoption rate might actually be a little higher than we expect. I know that the download statistics on Oracle JDK, somewhat surprisingly, are almost as high as they were for JDK 8. We're not sure why, but we're glad. So apparently a lot of people are kicking their tires. So if they're kicking the tires, what is next? Well, hopefully what's next is a bunch of adoption of JDK 9 by the whole ecosystem. have never, if you haven't contributed, if you did contribute to it, you don't get the raise. How many people have tried making on Java 9? How many people will use it in production? Okay, that's good. Why is that? Well, I understand there could be some trepidation because you may have heard that Java 9 breaks everything. Make that again. Well, that's not true. Java 9 breaks some things. Not all those everything breaks some things. Usually things that are, getting their fingers into internal APIs and doing all kinds of other nasty stuff. We know it breaks something. We try to walk a careful line of moving the platform forward while not breaking too much old stuff, assembled stuff. Sorry, it just needs to be taken out of shop. I mean, it just needs to be repaired and evolved for the future. We did take compatibility, especially around the specified part of the platform, the Java SE platform, as understood by the KCP. We took that seriously. That's one reason why all of this took so long. So I won't go into all the details here, but a lot of things do actually work on Java 9. We don't have to take my word for it. Shortly after 9 was released, I asked on Twitter, do you maintain a popular Java library framework for school? If it works fine on JDK 9, then please reply with its name and version. And I got a big pile of responses. Here's a summary. It's not exhaustive, but it has a lot of popular things on it. All of these things work fine on JDK 9. They either work without change, or in some cases their maintainers have to make a few modest changes. On this list, you will find the major IDEs, Eclipse and IntelliJ, the major build tools, and Gradle, test frameworks, JUnit, and TestNG, libraries, ByteBuddy, Jackson, Log4j, Hibernate, Juke, Netty, the entire Spring framework. So a whole bunch of stuff is here. If you're trying to run something on 9, one of the first things you should do is make sure you've upgraded all of your dependencies so that you have all this new stuff. All right, so it's time to adopt 9. But what comes after that? To understand more about the future, let's take a brief look at the past. For 20 years now, more than 20 years, Java has evolved in large, irregular, and somewhat unpredictable steps. Each release has had one or a few really big features in it, and the release has been held until those features are ready, adjusting the schedule as needed, sometimes more than once, which gets really people. That's good for big features, but it's not so good for smaller features, because it means a smaller feature that's done, well, it turns out 2 years before the release ships, was unavailable for people wanting it for 2 years. So we wound up with releases that are grand and majestic, but rather slow-moving. For Java to be competitive in this day and age, it not only has to move forward, it has to move forward faster. So that's why we're switching to a strict train model of releases. The new feature release every 6 months on a time-based schedule, goes out in 6 months, highly predictable, no matter what. Let's try to visualize this. Here's a timeline. We just shipped Java 9, September 2017. With a new feature release every 6 months, the next release will be in March of 2018. Ooh, that's just a few weeks away. Release after that will be in September of 2018. We'll do March of 2019, and so on and so forth. March, September, pattern here. Keep that going. Every feature release can contain any kind of feature, including a feature that removes an old feature. Features go in only when they're ready, only when they're nearly finished. There's going to be none of this, oh, this thing's 2/3 done, we want to put it in to get some feedback, and we'll just slip the release a couple of times until we're here it's finished. No. The beauty of the 6-month model is if you miss the current release, that's okay. Because there's another release just 6 months away. And I have to say, being almost done with the next one shipping in March, it's really a breath of fresh air when you realize, oh, this thing I've been working on, I wasn't quite ready. Oh, I can just push it in the main line in a couple more months and it'll be the next one. That's great. So in terms of how, the lifetimes of these releases, the notion is that contributors of JDK together will support each one of these feature releases for at least 3 months, or at least 6 months. So. Right. At least 6 months with 3 months quarterly updates. So at least 2, but no, at least. That doesn't mean that's very different from at most. Right? Get the boundary right. A 6-month release is fine if you're a leading edge developer, deploying something in the cloud that maybe and you update it whenever you need to. It's not so good for enterprises who are using more traditional app server type deployment, big job installations on big hardware, who really don't want to upgrade very often. So what we try to do is have a long-term support release every 3 years. So the release in September 2018 will be an LTS, and the release in September 2021 will be an LTS. And if this graph were a little bigger, it would show that JDK 8 in 9, it would be like way out here. JDK 8 is with the previous long-term support release. So we need some overlap. Excellent question. I'll refer you to a couple of slides. All right. Now there's a problem with what they call E9. Obviously, it's called 9. When I made this proposal last summer, I suggested naming scheme. To say that this did not go over well, there was a lot of feedback. Much of it emotional, but some of it was quite bad. I thank you if you sent it rational, clear feedback. If you sent it emotional feedback, I pretty much heard it. Anyway, we're not doing that. What we will do is a more sensible way, which is almost completely compatible with the new version scheme that we have already introduced in 9, which is just called a. Now, it did require some, modest tweaks to the version scheme that we introduced in 9, but we're hopefully not going to break too much. All right. So that's the plan for what goes on in OpenJDK. Contributions from everybody, not just Oracle. Those of us who work at Oracle are making some changes also. So the next slide, when I say we, I mean those of us who work into the Go. So amongst the changes, we are shipping GPL licensed OpenJDK in addition to the binary code licensed commercial Oracle JDK. These are already available for 9 and for the 10 early access releases at jdk.cal.net. So if you want, get them there. We are open sourcing all of the Oracle closed commercial features. I'm glad you're thrilled. I'm thrilled too because maintaining closed code that actually interacts with open code is an incredible cost for the engineering staff. Amongst the things, well, the primary things being open source are app CDS, the application class data sharing, which you will hear about later today, Java flight recorder, Java mission control, and the Zach garbage collector. App CDS is in JDK 10. ZGC, we open sourced it a few months ago, back in the fall. JFR and JMC are works in progress. Another change, Oracle engineers will focus primarily on Linux, macOS, and Windows on x64, and they'll spend relatively less effort on other ports. And finally, we're going to dedicate some staff to working with things that we've all wanted to do for OpenJDK. I just wanted to try to cap that up. See if we can go. Now, as with any enormous change, I know there are lots of worries and some confusion. So let me try to address those in my best Dave Letterman style. The top 5 misconceptions about release models. Number 1, non-LTS releases are experimental. It's just a fancy name for a beta. Wrong. The only difference is that LTS releases have a longer support timeline. You should not fall into the trap of thinking, oh, if my feature doesn't make it into this LTS, nobody's going to use it. Or I should plan this feature so that it's going to be in this LTS, or I can't deprecate it until the next day LTS. No. LTS, it's not even something that's necessarily uniform. You know, one implementer, one vendor could decide to do an LTS on every single feature release if they want to. Maybe there's business in that. I don't know. Number 2, Number 2, every feature release will be as disruptive as past feature releases. No. What's constant is the rate of innovation. The rate of innovation, which correlates very strongly with the rate of disruption, doesn't change. The rate of innovation will increase rather than introducing changes once every 3 years on another unpredictable schedule. We introduce changes every 6 months on a more predictable schedule. It's very cool. Number 3, to remove an old feature requires 3 years advance notice. No. To remove an outdated feature, what it really requires is a production-ready build that issues a suitable warning. It's possible for that to use is, because a working build with suitable warning is the ultimate release note. You can't ignore it. Well, you can ignore it after the first time you see it. You can't say, oh, it's some obscure release note I didn't see. As to how much time should pass between deprecating a feature and actually removing it, it's a matter of judgment. In some cases, 6 months will be adequate. In some cases, a year will be better. For something really big, yeah, maybe 2 or 3 years is a good interval. Number 4, if you maintain an infrequently migrated system, big app server, then you can just ignore the non-LTS releases. That would actually be a bad idea. If you're maintaining a system like that, you can test with each feature release. Because if you do that, then you'll be almost ready for the next LTS when it comes out, rather than having to do a bunch of work that all piles up at the end. Number 5, there will never be more than 2 updates for any non-LTS release. And there will never be more than 3 years of support for any LTS release. No. It all depends on who shows up. It all depends on where you're getting your builds from. Right? You might be paying some company for your builds. You might be doing them yourself. You might be building them on your own for OpenJDK. Whatever. It depends on who shows up and how you're getting your builds. Now, speaking of showing up, I know there is some concern about the extent to which Oracle will show up, will continue to show up. So I'd like to put some firm lines around that. In terms of commitments, what Oracle tends to do, so this is another one of these slides where we can those into Oracle. Oracle will lead and contribute to every JDK feature release. Oracle will lead and contribute to at least the first 2 quarterly updates of every JDK feature release. Oracle will publish OpenJDK builds under the GPL for at least the above releases, maybe more. Oracle will lead and contribute to the JDK updates project until at least January 2019. And we will do our best to ensure smooth leadership transitions, even when Oracle ever steps down from any of these roles. I know there's been a bit of a kerfuffle recently. We didn't do as well as we could have with the JDK 9 updates. Sorry. But I think that part of that is just throwing names around getting onto the 6-month model. We will make it work. But it is definitely extended if the situation warrants. But all I can say is these are the lower bounds that we can guarantee today. Okay, I'll take my Oracle hat off when the OpenJDK hat back on. The intent is that in the OpenJDK community there will be three years of support. Which contributors help make that happen is up to those who show up. If nobody shows up, then those LT and S3 users might not have 3 years of support. They might only have 6 months. They might have 12. I don't know. Oracle is not committing to do more than 6 months. It doesn't mean Oracle won't do more. I'm just saying what the commitment is. All right. So we've got this train model. We've got a release going out the door every 6 months. It's time-based. Time marches on. Like the tide, it waits for no one. It just goes. To feed this model, we have a pipeline of features and requirements. And well, yes, guess what? We actually have such a pipeline in our JDK. So JDK enhancement proposals, these are documents we've been using now for quite a few years, going back to JDK 7. Way to document proposals, get feedback on them, and ultimately follow something through the process of getting merged in mainline code. We've got quite a number of objects. The one of it, many of these were merged into A. Some of them still candidates, some of them have been closed, a few have been withdrawn. But anyway, lots of objects here. My goodness, we're in the 300s, aren't we? Yeah. Oh, and the really fun part is the unsubmitted draft gems at the bottom. This is where you can sometimes find stuff that's out by accident that the author didn't know to be published. So there's cool stuff in here, including some stuff that's been withdrawn, and of course you have oh yeah, and then a very recent popular one, raw string literal. There's a bike shed for you. Anyway, steps of the pipeline that feed the train model. So as we think about going from 9 to 10, the question is not what features are planned for 10. No, not doing waterfall. No, I'm sorry, Mr. Executive Vice President, I can't predict what is going to be in that release 1 year from now. I can make a guess, but it's just going to be a guess. So the question is what features are ready for 10? Here are the features that are ready for 10. These are the features that are in 10. Guess what? We're weeks away from shipping, so there aren't going to be any more than this. It's just these 12. I won't go through them all, but there is definitely some cool stuff here, including my modest contribution to the product. One thing I will dive into, just so I can say that I showed some code, is the first one, local variable type inputs. So it's a reasonably popular opinion that Java does not have type inference, but in fact Java has had type inference for many years. In Java 5, we introduced type inference along with generics, so that you didn't have to type this annoying string thing when you were invoking collections or empty list. You could just type the obvious thing. We introduced some more type inference in 7 with this concept, the diamond construct, so you can omit the type when you're invoking the constructor. Lambda in 8 included a whole bunch of type inference so that you didn't have to laboriously type out the type of every parameter in the Lambda expression. You could type the obvious thing and the compiler would go off and figure it out for you. Thank you, Mauricio. In 10, we have local variable type inference. Local variable type inference is meant to address situations like this, where you're looking at a line and it's like, oh my gosh, I've got this long type name, one of those canonical, this is why people make fun of Java sorts of things. Buffer reader this, new buffer reader that, blah, 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 what a pain in the butt. Why can't I just type bar? All the other cool, really graphic languages do this by now. So let's just do this in Java. So this is what we have in 10. The having of local in the name of feature support, it is local. You can't use this on a field. You can't use this on a return type of a method. It's really just for small scope of code that you're in total control of, and where you can actually make your code more readable by just typing No, don't worry, it's not JavaScript. It's not that. So, anything that's scheduled, as I said, we are weeks away, March 20th. For general availability, we are on the verge of building the first release candidate. That will be next Thursday. So keep your eyes on the notes. Moving on to 11. What features are going to be, what features can you guarantee will be in 11? I have no idea. But here are those that have been targeted so far. In fact, the first one, dynamic class file constants, was merged, well, mostly merged a few days ago. I think there's some stuff waiting for here to work, but that will get in. Dynamic class file constants is a cool feature. John Rose will tell you, I can tell you all about it. It basically does for class file constants what dynamic did for methods. We have Alexi's epsilon garbage collector. We are finally going to get rid of and then we're going to clean up some of the wearable type of stuff. Okay, time marches on. There are a bunch of bigger projects feeding into an even longer term pipeline. Some of these big projects have generated a few dEPs already. Some of them are still quite nascent and just getting started. Like for this year. Anyway, right, so Amber, this is a project Ryan Getz is leading. The aim of Amber is to right-size language feature, to reduce the amount of ceremony necessary to write with Java code, to help reduce boilerplate. Amber is designed to be a collection of features that come in over time. The local variable type is actually the first one, so Amber's already delivered something in 10, but there's a long-term vision, which you can see if you look at the JEPs. There are Amber used a bunch of JEPs, including one for a recent one for switch expressions, and raw-string literals is actually part of Amber, technically speaking. So there's actually a vision for how all that stuff will fit together, but be delivered in small ways. Loom, continuations and fibers for the Java virtual machine. Yay. I think this one's very cool. Metropolis, let's write a Java virtual machine in Java. So the first part of this is looking at taking the draw JIT compiler, which is written in Java, which is the basis of the experimental AOT compiler that's a 9, and using that, making that available as an experimental JIT compiler for future release, and eventually replacing C2 with that. Now, obviously, we're years away from that. It's not work. But we think that's a really promising fact. And anybody who works on C2, and many who don't, know that it's not a code base that has a whole lot of life left in it. Panama, foreign focused interface and data layout. This project actually has a pretty good prototype running already. I was playing with it last week. It's got a tool called JExtract. It uses libclang. You can throttle over a bunch of .h files and produce Java interfaces that look vaguely like what's in the .h files, so you can do some calls from Java. It's pretty neat. Portola, the Alpine Linux port that Michael's been leading. Shenandoah, Fine garbage collector. Valhalla, value types and specialized generics, another enormous project that takes years to produce results. And finally, ZDC, the Z garbage collector, which is a scalable low latency PC. So these are just examples of some of the bigger projects. You might notice there's a certain amount of overlap. There are two GCs here that have overlapping requirements and solution spaces. But I'm looking forward to these teams working together over time. Hopefully we can have one GC that addresses all of those requirements. Okay, so we've got all of these projects. We've got a bunch of smaller things in the works. All of this is intended to help Java moving forward faster stand by any confusing.
We're very much inside. We have to allow enough time to sort the room around